In this video, we are going to learn the second sub part of logarithm, that is laws of logarithm. Okay, so what it says is, let a be a positive number not equal to 1, that is a should be greater than 0 and a is not equal to 1. Let x1 and x2 be any positive numbers, that is x1 is greater than 0 and x2 is greater than 0, and n be any real number, that is n belongs to R. Then the first law is log of x1 times x2 to the base a, or log of x1 into x2 to the base a is equal to log of x1 to the base a plus log of x2 to the base a. The second law is log of x1 upon x2 to the base a is equal to log of x1 to the base a minus log of x2 to the base a. The third law is log of x1 to the power n to the base a is equal to n log of x1 to the base a. These are the three laws. Okay. So now let us start with the proof of first law. Let log of x1 to the base a is equal to p. This we are considering the RHS part here. Okay. And let log of x2 to the base a is equal to q. Now we'll convert this in index form, that is a to the power p is equal to x1, and this one will be a to the power q is equal to x2. Therefore x1 into x2 will be, or x1 times x2 will be, x1 into x2 will be a to the power p into a to the power q, which is nothing but x1 times x2 is equal to a to the power p plus q, which gives us log of x1 times x2 to the base a is equal to p plus q by definition. This will give us log of x1 times x2 to the base a is equal to log of x1 to the base a plus log of x2 to the base a, which will give us log of nothing but x1, x2, x3 and so on to the base a is equal to log of x1 to the base a plus log of x2 to the base a plus log of x3 to the base a and so on. Now this is aid to memory. Log of product to any base is equal to sum of logs of the factors to the same base. See, it says that log of product to any base is equal to the sum of the factors to the same base. Okay. Okay, now let's try an example. Log of 210 to the base a. Okay, this is the question. So first of all, what I'll do is factor out 210. 210. I'll factor it by 2 first. 2 ones are 2, 2 zeros are 0, 2 fives are 10. Now I'll factor it by 3. 3 threes are 9, 3 fives are 15. Now I'll factor it by 5. 5 sevens are 35. Now 7 goes 7 1 times, so I'll factor it by 7. So this is 1. So what I have is 2 into 3 into 5 into 7. Now this can be written as log to the base a 2 into 3 into 5 into 7. Then this is nothing but log of 2 to the base a plus log of 3 to the base a plus log of 5 to the base a plus log of 7 to the base a. Hence you have the answer, right? This is the product and this is the sum of logs, you know, of the factors to the same base. Okay. Now we'll go with the law 2, proof of law 2. Okay. The law 2 says log of x1 upon x2 to the base a is equal to log of x1 to the base a minus log of x2 to the base a. So x1 upon x2 is equal to, this will be a to the power p upon a to the power q, which is nothing but a to the power p minus q. which gives us log of x1 upon x2 to the base a is equal to p minus q. Now this came by definition, right? So log of x1 upon x2 to the base a is equal to log of x1 to the base a minus log of x2 to the base a. See, we already know that how did this a to the power p and a to the power q come, because we have considered that. I'll write the note here. Okay, log of x1 to the base a is equal to p. This is the first equation, right? We have used this in the earlier law also, law 1, and log of x2 to the base a is equal to q. This is the second equation, and that's why we got this a to the power p upon a to the power q. This is a corollary part. x1, x2, x3, and so on upon y1, y2, y3, and so on is equal to, this is nothing but log of x1 to the base a plus log of x2 to the base a plus log of x3 to the base a minus log of y1 to the base a plus log of y2 to the base a plus log of y3 to the base a. Now let's try an example of law 2. Log of 30 upon 1001 to the base 10. Okay. Now first I'll factor out 1001 because that is a big number. So first of all I'll factor it out. So let's see if it gets factored by 3. 3 3s are 9, 1, 3 3s are 9, 1 8 1 no. 7, 7 1s are 7, 7 4s are 20, yes. So I'll first factor it by 7. 7 1s are 7, carry over 3, 7 4s are 28, carry over 2, 7 3s are 21. Now 143. 143, I think it's a multiple of 11. Yeah, 11. 11 ones are 11, and its carry over is 3. 11 threes are 33. Now 13 divides 13 one times, so 13 ones are 13. So I have factor it out. Okay, so that would be, sorry, log to the base 10, 7 into 11 into 13 upon 30. 30 can be factored out as 2 15 ja, 3 5 ja, 5 ja, 2 into 3 into 5, 2 into 3 into 5. And this can be written as log of 2 to the base 10 plus log of 3 to the base 10 plus log of 5 to the base 10 minus log of 7 to the base 10 plus log of 11 to the base 10 plus log of 13 to the base 10, and this is your answer. Okay, so the aid to the memory says log of fraction is equal to log of numerator minus log of denominator. Now I just want to say something, that is the base is a, sorry, the base is a, sorry about that, I couldn't write that in the text format, so I have to write it like this. Okay, now let us start with the proof 3 of law. Okay, first of all give you a little bit of note, that is log of x1 to the base a is equal to p, this is your first equation, and log of x2 to the base a is equal to q is your second equation. Let log of x1 to the base a is equal to p, then by definition, or you can say we'll convert this to index form, will give us a to the power p is equal to x1. Now what I'll do is I'll raise both the sides, this both the sides to the nth power. Okay, so raising both sides to the power n. Now this will give us ap whole to the power n is equal to x1 to the power n. This will give us a to the power pn is equal to x1 to the power n. Now therefore, by definition of log, we have log of x1 to the power n to the base a is equal to np, which will give us n log x1 to the base a. This is from this equation 1. Sorry, I am a little bit wrong here. This shouldn't be this. This should be equal to. Now let's try an example of law 3. Log of x cube to the base a is equal to 3 log of x to the base a. Okay, this is the general example. I'll take another one. Log of 32 to the base 10. Now 32 can be written as 2 to the power 5. We know that 32 can be written as 2 to the power 5. So this becomes log of 2 to the power 5 to the base 10, right? Now this can be written as 5 log of 2 to the base 10. Okay. Uh, Third example, I'll consider it as 1, 2, 3. Log of root a plus b to the base m is equal to log of a plus b to the power half to the base m, which is nothing but half log of a plus b to the base m. There is a corollary. Log of x to the base a to the power n is equal to 1 upon n log of x to the base a. So the proof of this corollary is, let log of x to the base a to the power n is equal to p. This is your first equation. Then a to the power n whole to the power p is equal to x. This is, you have we have just converted this in index form or exponential form, you can say the proper word. Now this will give us a to the power np is equal to x, which will give us log of x to the base a is equal to np. Now this will give us p is equal to 1 upon n log of x to the base a, which will give us log of x to the base a to the power n is equal to 1 upon n log of x to the base a by 1. Now we'll try some examples on the corollary that we studied. So for example, log of 16 to the base 9 is equal to, so we know that 9 is square of 3. So log of 16 to the base 3 square. Okay, this can be written as 1 upon 2 log of 16 to the base 3 by the corollary that we studied. Okay, after the law law number 3. So I'll take one more example, that is log of x plus 1 to the base 8. Now this can be written as log of x plus 1 to the base 2 cube, which is nothing but 1 upon 3 log of x plus 1 to the base 2. And hence we have completed with our laws.